Hello everyone, and welcome to another discussion recording for CS184. Today's discussion is going to be about cameras. It's a relatively short one, but pretty useful, so let's get into it. Okay, so before we get into cameras, the first question has just a little bit of probability practice, so working with some PDFs. Okay, so let's go ahead and see what we have to do. Suppose we've sampled theta and phi separately with PDFs p theta and p phi. What is the PDF of sampling omega is equal to theta phi with respect to solid angle? And so there's a hint of how PDFs are transformed with px dx is equal to py dy. Okay, so using this hint, what we can do is we can start by writing probability omega d omega is equal to probability of theta phi d theta phi. Okay? Oh, actually, that's my bad. That should be d theta d phi. Okay, so that's just straight up using the hint. Nothing crazy there. From then on, we can just do some manipulation. So we get omega is equal to d phi over d omega, right? Just divided both sides by d omega, moved it over. Okay, now if you remember from discussion, I want to say not the one before this, but the one before that. So last week, we basically came to we found an equation that went a little something like this. Okay, and this was in the question related to the sphere and the solid angle. So we have this equation, d omega is equal to sine theta d phi, right? And so we can now go into the equation we have here and rewrite it. So we can go p omega is equal to p theta phi d theta d phi over sine theta d phi, right? Just plugging in that equation up there, and then we just cancel these out, and we get p of omega is equal to p theta phi times 1 over sine theta. Okay, it's a little bit of a weird way to write it, but it's still correct. Okay, so there we go. We just used the hint, did some math, brought in this equation from last time, and we got our answer. Okay, so just a little bit of review. Now let's get into the real meat of this discussion, and that is cameras and lenses. Okay, so we're starting off. There's a lot of terminology when it comes to cameras, so a lot of things to keep in mind, a lot of things to know, and in particular what's important is knowing how they all relate to one another. Okay, so in question number 1, what we're going to do is define a lot of these terms and see what they mean, and hopefully get some more understanding about cameras through that. Okay, so let's get started. And I'm just going to write kind of the highlights of what each of these terms are. I'm not going to go into too much depth here. Read the answer key for more in-depth information. Okay, so let's get started. A, focal length. So what is the focal length? The focal length is the distance between the center of the lens and the point at which, if parallel rays come into this lens, they're going to get, diverted to a certain point, and the point at which rays coming from infinity, so parallel rays, are brought into focus where they intersect, that's the second point. I'll call it the POI, or point of intersection, right? That's where the infinite rays coming into this lens, it looks a little something like this. So if we have the lens, infinite rays coming in, and they're all going to go ahead and meet right there, and that is our POI. Okay, so that's the focal length. It's the distance from the center of the lens to that, right? That F is our focal length. Okay, so let's keep going. So the next is the field of view. So the field of view, this might be a term that you've heard somewhere outside of talking about this class, somewhere outside of this class. It's a pretty simple term, and it's the extent of the scene visible and it's measured in angle. Okay, so we'll generally talk about field of view in terms of degrees. So there might be a horizontal field of view and a vertical field of view, maybe 60 degrees in each, or 30 in horizontal, 70 in vertical, it can vary. Okay, next up, the exposure. So exposure is kind of, it's not necessarily one specific term, but it's kind of this quantity that determines how light or dark the image will be. Right? And so this depends on 3 different settings, okay? So one of them is the aperture, which is, we'll get to it later, but it's the size of the opening, so how much light is coming into the camera. The next is shutter speed, which we will also talk about in just a second. And then the third one is the ISO, or gain, which is just a property which helps determine how much light is coming into the camera. Okay, so exposure, it determines how light and dark an image will be, and it depends on 3 things: the aperture, shutter speed, and the ISO, also called the gain. Okay, so let's keep going. Let's talk about shutter speed and aperture, which are involved in exposure, as we just mentioned. So shutter speed. So what the shutter speed is here, and I'll come up here. It's how fast the shutter opens and closes. Okay, so if you've ever seen a camera, kind of when you click the camera, something will open and then shut, and how fast that happens is the shutter speed. Okay, and so this obviously affects how light or dark your image will be, because if it's open for longer, more light is coming in. If it's super quick, the image will be comparatively darker. So that's what the shutter speed is. It's okay how fast or slow the shutter opens, and it affects how much light enters. Okay, so then the next one is the aperture. And the aperture, I kind of briefly mentioned this, but it's the size of the camera opening. Okay, so on those cameras that you can see, that you can buy, kind of there's an area where the light is coming in, and so the size of that, and this is often adjustable, you can kind of close it down a little bit, open a little bit, and so that's the size of the opening through which light enters the camera. Okay, and so this can be used also to affect how much light is coming in. Smaller hole, less light comes in; bigger hole, more light comes in. So that's how that will also affect the exposure. Okay. The next up is the f-stop. This is the ratio between focal length, right? The focal length, which we discussed earlier, and the aperture size. Okay, so just kind of a term that you can find given these 2 other terms, focal length and aperture, and it's the ratio between those 2. Okay, and it kind of gives us an easy way to have preset camera configurations. Okay, next up, the circle of confusion. So what the circle of confusion is basically oftentimes there's light rays coming into a cone, and they get focused, but they're not perfectly focused. Okay, so it's a kind of spot created by these light rays that aren't perfectly focused, and it's just a little bit of a blur. So created by not perfect focus. And to see some examples of this, I'd suggest checking out the lecture. There should be some images that give examples of the circle of confusion. Okay, and last but not least, the depth of field. And so this one's pretty simple. It's the range of depths that are in focus. Okay, so we know when you have camera, there's some areas where you can have focus. Oftentimes if something is too close to the camera, you can't quite bring in focus, or if it's too far, you can't quite bring in focus. So the depth of field is the range of depths that are in focus. Okay, so just these are some of the terms, and I've only given you kind of some basic definitions. For more details, read the answer key and check out the lecture, but this should be a good introduction to start with. Okay, so let's keep going. So now that we've kind of talked about all these terms, let's look at how they kind of work together, how they affect the images taking, how they affect how the camera works, all of that. Okay, so assuming the focal length is the distance between the sensor and the lens, how are the focal length and field of view related? Right? For a fixed sensor size, how does increasing the focal length affect the field of view? Okay, so let's think about this. So the answer to this is for a fixed, so if we keep the sensor size focused, if we keep the sensor size the same, if we keep it fixed, but we move it basically closer, right? Because the focal length is distance between the sensor and the lens. If we move the sensor closer to the lens, what we're going to realize is focal length and the field of view are inversely related. So if we have a shorter focal length, the light is going to have a wilder field of view on the camera, while if we have a longer focal length, so we're moving the sensor away, we're going to have a narrower amount of light hitting this camera, right? Because light expands outwards. So if the sensor is out, the sensor is far away, less of that fringe light will hit. So basically, focal length, let me write it this way, focal length and field of view are inversely related. Okay, so increasing the focal length leads to decreasing the field of view. Okay, let's keep going. So now, an image captured with a 50mm focal length is considered to have a normal field of view. What about an image taken with a 15mm focal length? Or what about 150mm focal length? Do these types of images have special names? Okay, so in number one, we talked about how focal length and field of view are inversely related. So when we go from 50mm to 15mm, right, focal length is going down, which means our field of view is going up, right? And so this does in fact have a special name, 15mm, and it's called a wide angle picture, right? A pretty intuitive name. Our field of view is wider, so it's a wide angle picture. And meanwhile, when we go from 50 to 150, our field of view is getting much smaller. And this also has a name, 150, and it's called a telephoto. Okay, not quite as intuitive a name, but that's the name. Okay, so when we have a big field of view, it's called wide angle. When we have a small field of view, it's called telephoto. Okay, let's keep going. Number 3. So which of the following camera configurations has the smallest field of view? Okay, and so before we do this, something we need to know is that there's a equation, and it goes, so let me put it up there. Field of view is equal to 2 times arctan of h over 2f. Okay, where h is the sensor size and f is the focal length. So what we can do now is we can just plug this in, right? Each one of these we have h and f given to us, so we just plug it in, get the answers. So feel free to do that math on your own. I'm just going to put the numbers out here. But so okay, so A is, if we plug this in, we're going to get that it has a field of view of 19.8 degrees. If we plug it in for B, we're going to get 18.43 degrees. And if we plug it in for C, we're going to get 56.31 degrees. So clearly, C has the biggest and B has the smallest. So, okay, there we go. So B is our answer, right? The smallest field of view, because only 18 degrees. Okay, let's keep going. So number 4, now we talked about focal length and field of view, the relations between those. But now let's talk about how are sensor size and field of view related to each other, right? So what happens to the field of view if I don't move my sensor but make it bigger? And what if you don't move it but make it smaller, right? So this is kind of an intuitive answer, but sensor size and field of view are directly related, right? Because if the sensor gets bigger, it can capture more light in more area. So, you can capture more light coming in from the scene, so your field of view will be bigger. Okay, so sensor size and field of view are directly related. Okay, so if we go larger sensor size, that corresponds to a larger field of view. Okay, pretty straightforward. Let's keep going. So now, the next question is, if my f number is increasing, then what can I deduce about the size of my aperture or my focal length? Okay, so let's come back here and figure out what the f number is first. So f-stop, it's the ratio between the focal length or the aperture, okay? So given this, if this is going up, right? So f is equal to focal length over aperture, right? The ratio between focal length and aperture. So if your f number is increasing, then what can you tell about either the aperture or the focal length, right? So one of two things could be happening. So one, your aperture is going down relative to focal length, right? If the aperture goes down relative to the focal length, then that means that the f number increases, right? Because the aperture is in the denominator. And the alternative is that your focal length is getting bigger relative to the aperture, right? Because focal length is in the numerator, so if that gets bigger, but aperture doesn't relatively get bigger also, then the f number will increase, like we are seeing in this problem. Okay, so those are the two options. Either the aperture is getting smaller relative to the focal length, or the focal length is getting bigger relative to the aperture. Okay, so let's keep moving. So to help reduce motion blur when you're taking these pictures, you can increase the shutter speed of the camera, which, the shutter speed is how long it's open for, how long light is hitting the sensor for. So you're reducing the amount of time the sensor is exposed to light. And so what are the trade-offs? And what can you do about these trade-offs, right? So remember that when we discussed exposure earlier up here, it said, how light or dark an image will be, and shutter speed was one of those things that affects this. So if we increase the shutter speed, that means less light is hitting, which means that the overall exposure is going to be lower. So what's going to happen? Exposure is going to be lower. And so what does that mean? That means our images will be darker, okay? So the exposure is a measure of how light or dark our image is. So if the exposure goes down, that means our images will be relatively darker if we increase the shutter speed. So that's the trade-off of doing this. And so now we can think about, well, now that we know the trade-offs, how can we mitigate these trade-offs? And so what we can do is we can look and say, what else affects the exposure, and how can we tweak that to increase the exposure and hopefully counteract this balance? And so one way we can do that is we could increase the size of the aperture, right? So let me say mitigate. Increase aperture, which will therefore increase the exposure and make the images lighter again. And hopefully, if we pick the right values, we can bring our images back to where they used to be. Okay, so that's the trade-off of doing this. The images will be darker, and we can mitigate that by changing the exposure again through the aperture. Okay, so let's keep going. So, how are depth of field and aperture size related? What happens to the depth of field if you reduce the size of the aperture? And what else happens if you reduce the size of the aperture? Okay, so this is also, so in this case, the depth of field, which I'm going to call DOF, and the aperture are inversely related. Okay, so that means if one goes up, the other one goes down, and vice versa. So they're inversely related, okay? And so let's think about this. So what that means is a smaller aperture size. So we have a smaller hole through which light can come in, is a larger depth of field, a larger range of images, or a larger range of depth in the image will be in focus. And meanwhile, if we have a larger aperture size, so if we make the hole bigger, we're going to have a smaller area that is in focus when we take these pictures. Okay, and so, but the next question is, what else happens if I reduce the size of my aperture, right? And we discussed this just above, is increasing the aperture. We did that to increase the exposure. So if we do reduce the aperture, it will also make the image darker, right? Because increasing the aperture makes increase the exposure, so decreasing the aperture will similarly decrease the exposure. So what else will happen? Exposure will go down, and so our images will be darker. Okay, so if we do, in fact, so we can make the aperture smaller, get a larger depth of field out of that, but the trade-off for that will be that now we'll have darker images. And conversely, if we want to get lighter images, we could increase the aperture, but the trade-off for that will have a smaller depth of field. Okay, so, last question. Briefly explain why photographers must choose between depth of field and motion blur for moving objects. Okay, so this is kind of putting together a lot of the ideas we talked about in the last few questions all into one. And so let's talk about this. So if we want a better depth of field, right? So what we could do is, for a better depth of field, what did we just talk about right up here? They're inversely related, right? So we could reduce aperture, right? Okay, cool. So we reduce the aperture, we get a bigger depth of field. But as we just talked about, reducing the aperture, so reducing the aperture leads to a darker image, right? Because the exposure goes down. Less light is reaching the sensor, and so we're going to have an overall darker image. Okay, so now we went ahead and got a better depth of field, a bigger depth of field, but at the same time we now have a darker image as a trade-off for that, right? Now let's say if we want to mitigate, let me erase that. Mitigate a darker image. How could we do that? Well, let's come up here, right, where we were talking about this. Well, what we could do is we could decrease the shutter speed. Right here we increased the shutter speed and the exposure went down, the images got darker. So if we do the opposite and decrease the shutter speed, basically make it slower, more time for light to get in, the images will be lighter again. Right, so we can increase the shutter speed. Oh, sorry, that's my bad, that should be decrease. So we're decreasing the shutter speed and correspondingly increasing the amount of time the shutter is open, right? And so, but as we talked about, once again, coming up here, why did we increase the shutter speed? In order to reduce the motion blur, right? And so if we do decrease the shutter speed, decrease shutter speed, then we're going to have more motion blur. Okay, so basically we started off, we wanted to have a better depth of field, so we reduced the aperture. Reducing the aperture meant we had a darker image. Then to undo this darker image, we said, hey, let's decrease the shutter speed, but decreasing the shutter speed means we have more motion blur. Okay, and so that's why basically in order to get better depth of field, we have to have more motion blur, or opposite. Okay, so that's kind of the trade-off photographers have to choose between depth of field and motion blur. Okay, that's all for this discussion. Thanks for watching. We'll be back next week with some animation, I believe.